Screen is visible to you, right? Yes. Somebody respond.
Yes, ma'am.
Right. So in today's class, we are going to talk about transport layer protocols. Okay. There are many protocols actually. To begin with, in the earlier case, we had something called as simple protocol. Okay. So this is our first protocol in the transport layer. Okay. It is a simple protocol as the name suggests. Okay. And it is a connectionless protocol. Okay. And one of the drawback that we were having is in case of simple protocol, it was neither bothering about the flow control or nor the error control. Okay, so neither flow or error control was implemented. Okay, so neither it was having. And whenever a sender, right, so this is a sender, and sender at the application layer, whenever the information is there, he will send the information to the transport layer. Now the transport layer, through the logical channel, he tries to communicate with the transport layer of the receiver. Say that whenever the sender is having an information to be sent to the transport layer, okay, the transport layer at the sender site, without knowing the situation of a receiver, that means the transport layer, whenever he gets a message, okay, he just throws, or he just sends the packets, or can tell he delivers the packet, okay, to the receiver without asking for a request, or he simply assumes, that means a sender, okay, he just assumes that receiver is anytime free, okay, anytime is ready to free, I mean accept the packets, and he'll never be overwhelmed. But in the practical situation, that is not the case, right? Receiver may not be always free, and may not be, he'll be having so much of capacity to accept all the packets, whatever is been like sent from the sender, right? So, but the sender assumes, in this particular case, sender assumes that receiver can immediately, like he can handle the packets, okay, whatever he receives, no, he can handle the packets. That means he'll never be overwhelmed, and he can take the packets anytime whenever it is being delivered. Okay, so that was the assumption that the simple protocol was having, and that is why, like, we didn't have any flow control or error control concepts in this simple protocol. It's just a simple protocol. The name is because sender will send the packets to the receiver, and no other concepts come into picture here. So the name, it is simple protocol, and it is a connectionless protocol. And we can better analyze this simple protocol using the FSMs. Okay, right. So this is the FSM of a simple protocol. Now initially what happens is, the sender, see, we are writing the FSM for both sender and the receiver. Okay, so here initially the sender will be in the ready state. That means until and unless an application layer, okay, so here is a process, okay, until unless an application layer has a packets to send it to the below layer, that is a transport layer, where the packets received from the application layer will be added with an header, and this is my data, and that will be conveyed to your destination, right? Destination transport layer, and he will decapsulate it, forward it to the respective process of the application layer. Okay, so what happens is, until he receives the packets from the application layer at the sender site, okay, the system will be in a ready state. Okay, so sender side, it should not send any packet until its application layer has a message. okay, to be sent to the transport layer. And at the same time, the receiver side, okay, so we'll see that this is the receiver side, okay. The receiver side, he cannot deliver a message to its application layer. That means from here to here, right? Okay, from the transport layer of a receiver to the application layer. He cannot send the packet, okay, until the packet arrives, right? Okay, so initially both will be in the what state? Ready state, right? So what happens is when an event occurs, that means we have a start process here. When an event occurs, okay, uh, uh, what happens is, say for example, the event is request, okay, which is coming from the application layer. So what is the request? That he has a packets to be sent to the transport layer, right? The transport layer, what it does, he make a packet and send it to the destination. Okay, so whenever an event occurs, it's very simple protocol, right? Whenever an event occurs, from the ready state, he will enter into an state where he will, because the request is received from the application layer, then at the transport layer, he will make a packet and he will send it to the destination. At the receiver end, okay, he will be also in the ready state initially. Okay, so whenever a packet is arrived, fine, he will try to deliver the packets to the respective process of the application layer, right? So that means like the sending machine here, he'll encapsulate the message and he will send it. At the receiving end, what happens? The receiver will decapsulate the message and send it to the respective process in the application layer, right? Okay, so next we'll talk about the same concept, okay, in the form of a flow diagram, right? So this is the flow diagram where it's an example of communication using the simple protocol. And as we know, it is very simple, and sender sends the packets one after the other without even thinking about the receiver, right? So that is what I told you previously, because it never even bothers what is the situation of a receiver. He just predicts or assumes that the receiver is anytime free and he will receive, right? Okay, so the flow diagram is comprises of, we have a sender, or you can call it as a client, and this is the server, right? Client and the server concept we are talking, and client process in the application layer, client transport layer, similarly server transport layer, and that will be forwarding it to the application layer, that is a server process. Okay, so with respect to the time, if we try to analyze, whenever there is a packet from the application layer to be forwarded, okay, he will send a request to the transport layer. Okay, that means requesting in the sense like I have a packet, to receive it, something like that, and that packet will be forwarded to the transport layer at the destination, and it will be forwarded by decapsulating the message. Okay, the only message will be arrived at the server process, and this happens without any what you can say techniques or control mechanisms included in this particular protocol, right? Any doubt with the simple protocol? Any doubt? Okay. Yes. Next, transport layer protocol we are talking is about the stop and wait protocol, and this is the second protocol which we are going to discuss. Okay, stop and wait protocol. And earlier we saw simple protocol, it was connection-less protocol, right? But here in this case, stop and wait protocol is a connection-oriented. Okay, so it is a connection-oriented protocol, and it uses both flow control and the error control. It uses flow and error control. So these mechanisms are being included here. Okay, and both the sender, okay, and the receiver here, they use the sliding window. Right? They use the sliding window. Okay, so basically what is a sliding window we are talking, we'll discuss it later. Okay, so consider that sliding window of size 1. Okay, what is the size of the sliding window we are talking? 1. Okay, that means 1 packet you can send to the destination. So window size itself you are fixing it as like 1. Okay, that's the sliding window size. Now what happens here is the sender, he sends a packet one at a time, right? Say that the sender is, from the application layer, the transport layer has formed one particular packet, and that packet will be comprises of a sequence number, that means a packet number, and you have a checksum to be detected in case if any error or what you can say, packet is disrupted or corrupted. Okay, so in order to have a clarification about the error, we add a checksum, okay, in the packet, and this is if you consider the remaining portion of the packet is there, right? So this is a packet format. So the packet will be now sent to the destination, right? The transport layer destination. Like once here, especially in case of stop and wait protocol, all right, one packet is sent at a time, right? One packet is sent, and at the receiver end what happens, the receiver should acknowledge the packet. Okay, that means after the sender sends the packet, he will wait till on the timer. Okay, that means this is the sending window, this is the receive window. Okay, and the sending window size is fixed here, which I have just considered 1. Okay, so 1 packet is sent and you're on your timer getting starts. Okay, so when the timer is running, the receiver, by that time he should receive the packet. Okay, and before the timer expires, he has to acknowledge back. Okay, so this is the acknowledgement packet which is sent from the receiver to the sender. Okay, and that acknowledgement packet comprises of acknowledgement number and the checksum, right? Checksum for what? Because you should receive a right acknowledgement. Okay, if the acknowledgement itself is corrupted, sender will discard the acknowledgement. Okay, in case if there is any corrupted acknowledgement is received. Fine, so for that, along with the acknowledgement number, checksum is added and it is been sent to the sender. Now the condition here is, if the okay, initially when the packet is arriving at the receiver side, okay, it is checked, and using the checksum, if it is correct, it will send it to the application layer, right? If the checksum is incorrect, what happens? If the checksum is incorrect, the packet will be discarded silently. The receiver discards the packet, okay, and he'll be silent only, that means he'll keep quiet for certain amount of time. Okay, so this silence of the receiver indicates, because here the timer will also expires and the receiver is also very silent, he has not acknowledged back anything because he has discarded the packet, right? What happens is, the sender, once the timer expires, okay, he assumes that receiver has not sent any acknowledgement. The silence of a receiver itself is a signal, okay, for a sender. That means he has not acknowledged back, right? So once the timer expires, the receiver will get an information, something like the silence of receiver itself is an information, right? Because he is not sending any acknowledgement packets. So he'll understand that the packet might be like corrupted or it is lost. Okay, so every time whenever the sender sends a packet, it starts a timer. Okay, and if an acknowledgement is received before the timer expires, the timer is stopped. Okay, then what happens? Sender sends the next packet. Okay, say that if the timer is expired and acknowledgement is not received, okay, sender has to resend the packet, assuming that the packet is either it is lost or it might be corrupted. Okay. Now we have an outline of the stop and wait protocol, which we can analyze using the FSM. Okay, and one of the option that we have is your stop and wait protocol is a connection oriented protocol which provides both flow and error control, right? FSM. Okay. So sequence number, yeah, especially with respect to sequence number, because every packet you are sending by giving a sequence number, right? So whenever, see, I have a packet and that is attached with the sequence number, and the sequence number you will be having a checksum, and remaining is the data, right? That is the packet information or payload, you call it as. So here I told you the sequence number, right? See, why you give a sequence number? First of all, in order to prevent the duplicate packets. That means if I give the packet is 1, the sequence number is 1. Okay. At the receiver end, whenever he sees the packet, he will assume it is okay, packet 1 is received. But if I don't give the sequence number, possibility that, see what happens in the channel, if it is, I'll consider wired or wireless means, there may be like a possibility that the same packet may, because of the violation of the what you can say, rules in the transmission, okay, possibility of that same packet might be received to the destination multiple times. Okay, so that may cause the duplication of the packets, and receiver will never be knowing if you don't give the sequence number, right? So the same information might be like received twice. So this protocol uses the sequence number and acknowledgement numbers. Okay, but did you see the same concept in the simple protocol earlier? No, right? So this protocol uses the sequence number and the acknowledgement number. Okay, and here a field is added to the packet header to hold the sequence number. And here when we talk about the, I think I've told you about the sequence number earlier, but still let us have a continuation of how the protocols is going to formed in the especially transport layer. With respect to stop and wait protocol, this is the protocol, I mean it's the second protocol where we are introduce the sequence numbers, acknowledgement numbers, error control, flow control concepts. Okay, so assume that here I have a sequence number X. Okay, we need only, we only need to use X plus 1 after that. Okay, there is no need for X plus 2. What is this meaning of X and X plus 1? What is the meaning of X and X plus 1? Say for example, I have a sequence number, right? It will definitely consume one byte of your packet, right? Now the 1 byte is already consumed. What happens is when you send the information to the receiver, okay, he has to resend the information or acknowledgement for the same sequence number of the packet, right? So where x and x plus 1 is utilized, okay, or consumed, that 1 byte of space or the information is like consumed by both the senders and the receiver end, okay, just to identify the sequence number, right? So to show this, okay, assume that a sender has sent the packet with the sequence number X. Okay, so what and all can happen? What and all can happen? Some of the options may happen, right? So say consider that three conditions will take. One, the packet is arriving at the destination which is safe and sound. Okay, and receiver also sends the acknowledgement within the timer. Within, that means before the timer expires, okay, the receiver has sent an acknowledgement. Now the acknowledgement which is arriving at the sender side, he it also causes the sender to send the next packet which is numbered with x plus 1. Correct? That means you are telling the sender, receiver is telling the sender that you send me the next packet which is numbered x plus 1. So in order to tell that, you have to again send a sequence number along with your acknowledgement, right? So definitely I could say that x and x plus 1 are the 2 bytes of information, 2 bytes which has been like consumed by the sender and the receiver, where I told sequence numbers are utilized. Second case may happen that if I send a packet X with a sequence number, X is a sequence number, in case if the packet is corrupted at the destination, whenever like it has been sent from the sender, or the case may happen when it may never arrive at the receiver site at all. That means possibility that the receiver might have not received the packet, maybe because of some intermediate problems, right? The sender, it will wait until the timer times out, okay, and he will resend that particular packet which is numbered as X, okay, and the receiver should return an acknowledgement for that respective packet whatever you are sending. Okay, so this is the second case. Third case, the packet may arrive at the receiver site, okay, and receiver will also send an acknowledgement, but while receiving the acknowledgement is corrupted or it may be lost. That means receiver has sent the acknowledgement, but sender has not received, or sometimes sender might have received and the acknowledgement is corrupted. Okay, in that case also sender will discard the acknowledgement. Okay, why he will discard? Because it might have been corrupted, possibilities, right? So again what he will do, sender again, see, though that receiver has received, see, I am telling the case where receiver has received a packet and he has acknowledged, but there is a problem in the acknowledgement, correct? So what it will do, sender will discard this acknowledgement, again he will resend the same packet. I mean, sender will resend the same packet, thinking that whatever is the acknowledgement is received is like it's corrupted, or it might be like he might have not received the acknowledgement sometimes, though that receiver has sent the acknowledgement to the sender, correct? So in such situation, what happens, there may be possibility that sender will resend the packet to the receiver, right? So again there is a duplication of the packet at the receiver end. Okay, so receiver will recognize this, and he will try to discard the duplicate packet whatever he has received. Okay, um, yeah, and receiver will be waiting for, already he has acknowledged the X packet, correct, but he will be waiting for X plus 1th packet. Agree? In case, if I have a sender, I have a receiver, okay, sender has sent the data and a receiver also has acknowledged the data, but that is not reached the sender. Okay, but what is the receiver situation? Thinking that receiver is acknowledged, he'll be waiting for the next packet X plus 1. Correct, no? Which has to be like sent from the sender. But again, we can see that there is a need for sequence number in all, I think all the cases we need almost. Okay, but only in the case 1, that is case 1 is also packet is sent and acknowledged. Yeah. Okay, till here it is clear. Any doubt? Please respond. Am I audible to all of you? Hello. ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? Am I audible?
Yes, ma'am, it's audible.
Yeah, please somebody respond at least. Is it clear? Did you understand this?
Yes, ma'am.
So I think the situation occurs where I may require x and x plus 1, okay, numbering for the first and the third case, okay, because otherwise what happens if I don't use the sequence number, possibility that I may get a duplicated packet or acknowledgement for the same packets which has been like sent, multiple acknowledgements or disrupted corrupted acknowledgements. So possibilities might be like more, right? So we need the sequence number for first and third, but there is no need for a packet like x plus 2 here, okay. I don't require that x plus 2 sequence number. That is why we make use of x and x plus 1 as a sequence number, okay. That means in case 1, if I consider, okay, this is the first case, if I consider this, a packet, if I represent it as x with a sequence number, okay, and x plus 1 as an acknowledgement, okay, probably there is no ambiguity. But in case of case 2 and case 3, okay, the new packet, if I take as x plus 1, okay, and not x plus 2, if I don't take it as x plus 2, okay, so new packet I have taken as x plus 1, and yeah, but the case is here, if only x and x plus 1 are needed, okay, we can let that x is equal to 0 and x plus 1 to be equal to 1, okay. This means, like, say for example, I have a sequence that 0 1 0 1 0, okay. This is the order or the sequence that I try to give it, because initially what I choose, x is equal to 0, x plus 1 is equal to 1. So the sequence becomes 0 1 0 1 0 1, like that, so on, okay. So basically this refers to a modulo 2 arithmetic. See, modulo 2 arithmetic. So we give it as 2 power m is the sequence number. The range becomes 0 to 2 power m minus 1. Okay. Say for example, if I have m is equal to 4, okay, or 4 or 3, whatever you take, 3 I'll take, okay. So 0 to 2 power 3 minus 1, it would have been like 8 minus 1, 0 to 7. So the sequence would have been like 0 1 2 3 4 5 6 7 7, followed by 0 1 2 3 4 5 6 7, like that, okay. So this is how the sequencing is done for the respective sequence numbers, right? And next, with respect to this stop and wait protocol, the acknowledgement numbers are also been added here, right? And here, since the sequence numbers, whatever we give for the packets, okay, it must be suitable for both the data packets as well as the acknowledgement packets, because I cannot say say for example, one is the data which is being received by the receiver, the acknowledgement has to be sent for the same packet, right? So the numbering of acknowledgement is also been, I mean, it is also very important. The acknowledgement numbers always it advertise or announce that the sequence number of the next packet which is expected by the receiver will be sent. That means if a sender is sending X packet to the receiver, okay, receiver will send X plus 1 that I am expecting to the sender, right? Okay, so that is how the acknowledgement numbers are framed and it is assigned to the packets, okay. Now to have analysis of this stop and wait protocol, we can talk in terms of FSM, okay. It's a better way of analyzing certain protocols or the networks, right? So finite state machines, for the stop and wait protocol we have shown here, And FSM for sender, similarly how we analyzed for simple protocol, we are analyzing for stop and wait protocol at both the sender's site and at the receiver's site. Okay. Now consider that the FSM comprises, or the protocol works in such a way that we have two states here, right? So what are the two states? One is a ready state, second one is the blocking state or blocked state, right? So since the stop and wait protocol is a connection oriented protocol, okay, both the ends should be in the established state. Okay, that means like a ready state, or you call it as an established state. Okay, before they actually exchange the data packets. Fine. So these established states are nested in the, nested in the sense, say for example, I have an established state, if you call, okay, that is nested as like ready and the blocking state. Ready and the blocking state. Fine. So that is what is called as nested. Nested is again, it's a subcategory, you call it as. Fine. Now initially what happens at the sender's site, the system, the sender is initially, he will be in the ready state. Okay, but it can move between the ready and the blocking state, right? Ready to blocking state based on the event which is occurring, okay, which shows the start. You can see here the start happens, or it is activated. Earlier it will be in the ready state, it will be activated whenever there is an event occurs, right? So whenever there is a request which is coming from the application layer, and if the request is received, the transport layer using the stop and wait protocol, it makes a packet with the respective sequence number and saves that copy in the buffer location, because once it is sent, no, it should keep a copy in order to resend if the acknowledgement is not received. Correct? So what it should do, save a copy and send it. After that, start the timer. So this is all the works that it has to do it. Right? So in the ready state, like this is the event, these are all the things what is happening here. Okay, and then it moves to the blocking state, right? So what happens in the blocking state? Now in the blocking state, whenever the sender is sent the information, okay, he should keep quiet, right, until the acknowledgement is received. So he will enter into the blocked state. That means he'll be silent till the acknowledgement is received. Okay. So one condition is, in case if it is timeout occurs, he has to resend the packet in the window and restart the timer. Okay. Second condition, in case if it is received a corrupted acknowledgement, okay, or error free acknowledgement with acknowledgement number which is not related to that particular packet. See, there is a possibility again the acknowledgements may be like in a not proper orderly manner, it might not be received. Correct, no? So in such situation, you may have to, the sender may have to discard the acknowledgement. Okay. So that is what is this to looping which is shown here for block state. Fine. So initially he will send the packet. After sending, he has to wait. So during the wait state, he will enter into the block state. That is blocking condition. Now what happens in case there is an acknowledgement which is received, which again it's an error free. Okay. And the acknowledgement number is also like S+1 for the S sequence number packet. Then the window gets slide forward to S+1. That means we are analyzing in the form of a sliding window of window size 1 here. Okay, I'll tell you about sliding window next. But keep in mind that here the increment gets happen. That means your S packet is sent and the next packet will be incremented to S+1. Okay, that means it slides to S+1. Now sender has to get from its buffer S+1 packet to send it to the receiver. Correct, no? So this is how the S plus, I mean, FSM of the sender side works. Okay. Again here, mm, the receiver end. Okay, so initially again receiver will be in the ready state. Okay, till the any event occurs, right? Now there may be possibility that three events may occur here. First condition, if an error free packet with the sequence number R is arrived. Okay, then the message in the packet is delivered to the application layer. Correct. Then what happens, the window gets again, the receiver window slides forward to R plus 1 and send the acknowledgement number, say called as R. Okay, here we are talking in terms of R for the S in the sender side, R in the receiver side. Then what happens after, this is the first condition, three things can happen, right? So first is it might receive an error free packet with the sequence number, proper sequence number. Second condition, it may receive the error free packet, okay, with sequence number but not equal to R, that means what is expected, right? So then that time the receiver should discard the packet. If it is duplicate also it will discard, if it is not the proper sequence number also discards. Okay, then send an acknowledgement for R. Okay, if at all, okay, this is the case if it is like duplicate, and it will discard the packet and send the acknowledgement for R. Fine. Third condition is, if at all a corrupted packet is received, okay, then the packet has to be discarded, right? So this is how the FSM of the stop and wait protocol need to be analyzed, right? And you have to write the FSM. Okay, next, what is the efficiency of this stop and wait protocol? So if we see that efficiency, this is very inefficient. Okay, stop and wait protocol is very inefficient if our channel is again thick and it is too long. Okay, so basically what is the thick means, like it is a larger bandwidth, because definitely for higher data rates and all. Okay, and also if it is lengthy, that means the delay is more, right? So in such situation, the bandwidth delay product, if we try to analyze, it would have been like too high, and definitely it is not at all an efficient protocol that I use it. Okay, because when you talk about the bandwidth, if it is too high and also the delay is too more, system obviously you tell it is not efficient. Okay, because the round trip time delay or the propagation delay, okay, whatever we call, it is too much that to send one packet it would have been taken in terms of seconds or some more time, right? So what is bandwidth product delay product? It's a measure of the number of bits a sender can transmit through the system while waiting for an acknowledgement from the receiver. Okay, so the bandwidth delay product is a measure of number of bits a sender can transmit through the system while waiting for an acknowledgement from the receiver. So that becomes like more, again systems is going to lack its efficiency. Okay, next concept is, we can talk about the, I mean, we know that it is not so much efficient. Stop and wait protocol is not an efficient thing, because, and one more thing I'll tell you, you're sending one packet at a time, so definitely it is an inefficient. Okay, next is pipelining. Okay, so when I talk about pipelining, see, you are making the packets. Okay, like send the packets in a pipelined way. That means say for example, okay, this is a sender. Okay, I have a receiver here. What happens is, in the first time, okay, first duration, one packet is sent. Okay, now by the time the acknowledgement is received, okay, that means you think that after, I mean, this is the time duration for one packet to reach the destination. and think that after it receives, then only the acknowledgement is received for one, correct? That is from the receiver. So for that also it takes some time, correct? So let me take that it will to reach this is one microseconds or so. Okay, 1 second, and at the second 2 seconds it will receive the acknowledgement. By then that pipelining is like, by the time it receives the acknowledgement, okay, the sender will keep it the next packet ready, okay, in its buffer location to immediately transmit at the same time. So pipelining is that concept where it is not implemented in the stop and wait protocol. Okay, that means there is no pipelining in stop and wait protocol because the sender must wait for the packet to reach the destination and it has to be acknowledged. Okay, so that concept of, because if he keeps ready in its buffer the second packet to send it, no, that is of no use because he has to receive a acknowledgement for the first one, right? So that becomes again an inefficiency of the stop and wait protocol. But however, if we try to understand pipelining does, you can apply it to the next protocols whatever we'll be discussing. Okay, but here in case of stop and wait protocol we don't have pipelining concept. Okay, but in case if at all it would have been there in this particular protocol, no, definitely we could have seen some efficiency, and that efficiency would reflect in the delay. If that is there, I mean delay is less, okay, it would have been reflected in the bandwidth delay product. Okay, so by then probably it would have been increased the efficiency of the transmission, right? And definitely pipelining itself is a concept where it improves the efficiency, and you can send like more number of bits in the I mean in a larger bandwidth, okay, or you can send more number of bits which are pipelined. Okay, so one after the other immediately you could have sent the information package to the destination, right? So here since it is not there, pipelining is not there, okay, the stop and wait protocol goes still more inefficient. Okay, this is the second protocol which we have discussed. Any doubt? Doubts with the stop and wait protocol? Yes. So the next protocol is go back in protocol. I'll be doing it in the next class. All you want to, any queries, please let me know.